started here.
Okay.
This first question, just want to verify that there's no multiple choice for this. It's just a free response type of question. Is that right?
I'm pretty sure it's just a response question. I can double check.
Sure. Yeah. So the way to do this is to remember that when you're given f of x and you're given f inverse of x, let's just say you know that the ordered pair 1, 1 is on f of x.
Yeah.
This is not a great example, but you end up switching x and y, and that's also on the inverse. Okay. Now you'll see, so we actually have our answer there, but let's look at a couple more points here. So 2, 0. This means that you switch x and y to 0, 2.
Okay.
So let me do that in red here. Try and plot that point in red. There's that point there. And we need like one more to get kind of a good feel for this. So let's use this point down there, 0, -2. So we switch them, it's -2, 0. And that's the relationship between the ordered pairs. They swap x and y.
Okay, so there was a multiple choice. It was 0, -2, 1, -1, 2, 0, and 3, 3. So I can see that the 0, -2 is on there. And
yeah. Now I actually messed up the graph of this slightly. But we're gonna get it here in a moment.
yeah, that's fair.
So I put this in the wrong place. So we're basically looking for the point where when you swap it, it's exactly the same point.
Okay.
Now these things are mirrored over this line called y equals x, which looks like this. You've seen that before.
Yes, I have.
And that sort of gives you the answer there.
Okay.
3, because when you switch 3, 3, you get itself, and that's how you know that it intersects.
Okay, that makes sense. I don't know why, but the graphs confuse me.
Sure. Yeah. Well, these are challenging questions. I'm starting to get a feel for what you're doing here, and it's very difficult. So, which graph shows a function whose inverse is also a function? Okay, so let me try to answer this by showing you why the other answers are wrong, because you'll gain something from that.
That would be great.
And then we'll give you the right answer, because I'm sure you need that. So the blue is the original function.
Yeah.
A function must pass, and you probably saw this or heard this before, the vertical line test.
Yes, in the horizontal line test, I know both.
So that's slightly different. So for a function, it's just the vertical line test. So what that means, and imagine the red isn't there. Okay.
Yes.
If I were to draw a vertical line, do you see that it just hits the blue one time?
And
it just hits it one time there. So the blue is a function, yes. But the red, if I hit it with a vertical line, how many times does it intersect?
Twice.
2 times. There, it's 2 times. So it is not a function.
Okay, I get that.
Okay, so let's look at the next one here. Is the red a function? And your answer is, well, let me draw a vertical line. And does it hit it more than once? Now, do you see how these hit it twice?
Yes.
Now, if you said, hey, Matthew, what about right over here? I would say, well, yeah, like right there, it only hits it once, but everywhere else it hits it twice.
Right.
So
that
you only
one
have to,
time that it only hits it once doesn't count for the other times.
Yeah, you have to find, only have to find one exception. Okay, so you're probably getting a good feel here that what is probably the correct answer. But let's look at one more that is not correct, just to continue with this idea that, okay, here we go. So this graph right here, I'm going to blow it up just a little bit. You could say, hey, Matthew, I hit it one time. I hit it one time. And I would say you're right. But here you hit it 1, 2, 3 times. So if a vertical line hits it more than once,
Right.
it is not a function.
Right. Okay.
Now there's an important sort of aside here, like why do we care about this? And I can give you the answer to that, but let's just get through a few more of these questions. Like there is a practical interpretation here for this, but so the correct answer is the first graph that's shown, letter A, I'm assuming.
Right.
And the reason it's correct is for the same reasons that the other ones were incorrect. When you draw a vertical line, only hits it once. Just because these overlap, you're looking at them individually. So it's like, how many times does it hit the blue? Well, it hits the blue one time. Now you could also say, well, hey, Matthew, what about over here? It doesn't hit it at all. It's not defined over there. So
Right.
we actually can't do that. You can only do it where it's defined.
Okay.
So this is your final answer.
Okay, that makes sense. Okay, that makes more sense.
Okay. All right. So number one here, this is, I don't know what the order is, but this one is labeled number one. Okay.
Yeah.
All right. Now I'm going to ask you, have you ever used Desmos?
Huh?
You said no, or you don't know what I'm talking about. Is that right?
That's probably right.
Okay. So here's what I'm going to do. I'm going to share my screen and let me see. All right. So I'm going to new share. And this is it seems like you're doing an online program here, so you should get used to using some online tools. We're going to graph.
Oh, demos. Yeah, I know what that is.
Okay.
I couldn't hear you correctly.
I apologize for not speaking clearly. So we're going to graph these, and for now, just look on my screen. I mean, you're welcome to graph these along with me, and we can also use your calculator. But for a function to have an inverse, it has to pass what is called the horizontal line test. Okay.
Oh, so that's the inverse, and the vertical
Yes.
is if it's a function.
So if I draw this line, it only hits it one time, but if I draw this line, it hits it 2 times.
Right.
So this does not pass the horizontal line test, I'm sorry. So if it does not pass the horizontal line test, it does not have an inverse.
Okay.
So if you're looking at your problem there, see how the first one is x squared plus 3?
Yes.
That one's out. That's no good. Okay. Now let's go to the last one. The last one is y equals absolute value of x. And if you don't know where the functions are, you go to this keyboard here, and there's functions there. You can get all the ones you need for this.
Okay.
So same question. Does this pass the horizontal line test? Does a horizontal line hit it more than once or just once? And you would say it hits it twice. So this does not pass the horizontal line test. So this one is not a function.
Okay.
So now we're down to B and C. Let's look at B. B is y equals -9.
Right.
Okay, so let me go zoom out so we can find that. So there's y equals -9. If I draw another line at -9, do you see how it changed colors there?
Yes, it did.
That's because this line hits it everywhere. It overlaps.
Okay.
Okay, it's completely on top. Like imagine one book's on top of another. They're touching everywhere, and that's what's happening here.
Okay.
Okay, so now let's talk about what is the correct answer. The correct answer is C, -7x. Notice this line goes down and to the right. So a horizontal line is only going to hit it one time.
Right.
And that's how you know that it has an inverse, because it hits it one time.
Okay.
So I'm going to go back to sharing the other screen here. But an inverse, it means it passes the horizontal line test, meaning it only hits it one time.
Got it. That makes more sense. So would you
Alright.
say it's better to like graph most of the answers? I mean, I know you're probably still going through the other questions, but like for most of the answers, do you think it's like easier to do that way?
You gain a lot especially if you're a visual learner. You really do gain a lot from graphing it. And I like the Desmos tool because it's colorful, it's kind of intuitive. You zoom in and out the same way you do on other devices. So, it maybe if they say don't graph it, I'm still okay with you graphing it because I want you to see what it looks like.
Right. Okay, that makes sense.
Okay, so I'm just scrolling through the rest of it just to see what other problems here you've got, to see if there's an order here that makes more sense than another. Okay, so let's do number 2 next.
Okay.
Number 2. Okay, so it says if f of x and f inverse of x are inverse functions of each one another, and f of x equals 2x plus 5,
Mhm.
what is f inverse of 8? So there's really 2 approaches here. The first approach that makes the most sense is to determine the inverse function. And that's a skill you need to have. So we're going to actually do that here. The other way
Okay.
is to use some other techniques, but to determine the inverse, it's what I call a recipe. It's a certain number of steps that you have to go through. You have to follow them in order. Just follow along here. So the first step is to, instead of writing f of x, you write y equals 2x plus 5.
Okay.
That's kind of step 1. Some don't say it's a step. We'll call it step 1. Step 2 is to switch x and y. So x equals 2y plus 5. Step 3 is to solve for y.
Okay. So we would minus the 5, right?
That's right. You subtract 5 from both sides, and then you divide by 2.
Right.
So I'm going to rewrite it here. It's y equals x minus 5 over 2.
Mhm.
And this is the inverse. This new thing you found is the inverse.
Oh, okay. So I'm not
That
supposed to like somehow simplify it in some
no,
way.
this is correct as is. Now we go back to the original question. Whenever you get caught up here, the original question says to find f inverse of 8. So that literally means wherever you see an x to put an 8 in. So see how there's an x here, it's gonna be 8,
Oh,
right?
okay. So then we get 3 over 2.
That's your final answer. And if you go back and look, you'll see that that's letter B.
Oh. Oh, okay. That makes more sense. Yeah, I don't know how I got that wrong. I was trying to do it by myself, and the 8 was confusing me. And I wasn't really sure what I was supposed to do with the 8. I mean, I know like in parentheses it's supposed to be the X, but I didn't know when you're supposed to put the X into the A.
Yeah, it's a bit this recipe, how you find the inverse, we're going to use in some other questions also.
Okay.
So actually we're going to use that. We're going to kind of use it for 7. It looks like the answers to 7 either are cut off. They're on the next page. But we're going to look at 7 next because it kind of follows nicely from this one.
Mhm.
All right. So I know this says a lot. Let's look at this first one right here.
Okay.
And let's find its inverse. So step 1 is to put a y. Y equals 5x minus 25.
Okay.
Step 2 is to switch x and y.
Okay.
Step 3 is to solve for y.
Okay. Add the 25.
Add the 25, good.
X plus 25 equals 5y, and divide the 5.
Divide by 5, good.
Okay.
Now, your answer up above doesn't look like this. So here you do have to divide, and it's not a choice. You have to divide both of them by 5.
Okay.
So it's x over 5 plus 25 over 5,
Oh,
which is x over 5 plus 5.
right. So you simplify. Oh,
Now I don't know what the answers are for 7, but it probably is referring to what is called composition, f bubble g of x, or g bubble f of x. We did that last week when
right. Yeah.
okay, we can talk about that, but let's go back. We're going to look at some other questions before we get to that, but the answers are not printed on the thing that I saw. So
Yeah. James knew how that happened. It did not happen. But I understand what you gave me. So I'm sure. I'll
excellent,
figure it out.
excellent. Okay. Yeah, let's do this here. So we got question number 3. It says that g of x is the inverse of f of x.
Yeah.
So remember I said that you switch the x and the y's.
Yes.
So here's f of x. So g of x, which is the inverse, you're gonna switch your x's and your y's here. So instead of minus 6, 1, it's gonna be 1 minus 6. Instead of minus 3, 2, it's gonna be 2 minus 3. Instead of 2, 5, 5 and then a 2, and so on.
Okay.
You're switching the x's and the y's.
Okay. That makes sense.
Okay, so now we can do this, okay? Whereas before, it would have been very unclear how to do this, but do you understand why we switch the x and the y's?
Yeah, because that's how you do it for the other problem. So
for the
doing it with a chart
Yes,
doesn't make a difference. Well, it does, but it doesn't.
okay, yes. So g of 2 means that x is what value?
Means it's 5.
It means that x is 2.
Right.
Right, this is the x value. So what is the output? What is the output of that? That's this row right here.
X. Okay, that makes sense.
So I need the number over here. What goes over here to the right? X is 2, y is
-3.
-3. Okay. Now you're using the result. See, this -3 is this g of 2. So you're trying to find f of g of 2, but this g of 2 you just found, it's -3.
Yeah.
So -3 takes the place of g of 2. Now you're going to find f of -3. This is your x value again, but you go over to this other table.
Oh, okay. So then it's 2?
It's 2. Yes.
That was confusing. Why did we undo what we just did? Sorry.
That's just, yeah, it's the way the way it goes here. So it's not a complicated question, because it's true that when you take the f of the inverse of the number, which is what we did here,
Right.
it always returns the number. Like, let's look at another example. What is f of g of 3? So you're going to first tell me, well, what is g of 3? G of 3 is
5.
5. What is f of 5?
F of 5 is 3.
Yes. So what you're seeing is that if functions are inverses of each other, if f of x and g of x, if they're inverses of each other, then f of g of a number always equals the number, and g of f of the number always equals the number.
Okay.
That's what we just did in this last problem.
Got it. It's really hard because it doesn't have a point really.
Yeah.
So-
Well, yeah. So yeah, I mean, I'll try to give you some, real legitimate, application of this, but let's continue here. So 4, which of the following statements could be used to explain why f of x equals 2x minus 3 has an inverse relation? Do you know what this graph looks like? Could you describe it to me?
Oh, this one did not have a graph. Oh,
Right,
do you mean
right.
like
But
me
could you
graphing
graph
it?
it? Yeah, like could you quickly tell me, like, does it, let me use a couple of different things here. Is it this? Is it this? Is it this? Is it, can you give me some description of the graph here? Like, what is the -3 and what is the 2?
The 2 is the x value
Slope,
slope, and then the 3 is the y.
y-intercept. So it goes through -3 and has a slope of 2, so it goes up 2, right 1, up 2, right 1. So it's a graph that looks like this.
Oh, okay.
Now, if you couldn't remember how to do that, where are you going to graph it now?
Right.
You're going to go, you're going to go to Desmos and you're going to graph it, or grab your graphing calculator and graph it. Now, why does this have an inverse? Just if you look at the graph here, what does it pass?
It passes through here.
What did we do? Let's scroll up here. What did we do in this graphical problem here? What did I do over and over again, starting here?
Do a vertical line test.
And that was to test it was a function, right?
Right.
Okay. For an inverse, what does it have to pass?
The horizontal line test.
So draw a horizontal line, pick your favorite horizontal line. How many times does it hit the graph?
Once.
How about this one?
Once.
Does it pass the horizontal line test?
Yes.
Okay. Now, it is also true that it is 1-to-1.
Okay, I've heard that, but I don't understand that one.
It's just another name for inverse.
Okay, because it only goes through the line once.
Yeah, you can, yeah, but they're just synonyms in the math world.
Okay.
Like there's other ones that, but was this like a choose one, or was it a,
It was a choose one.
okay. So the correct answer is not this one that I first circled,
Okay.
because the one that I first circled here says the graph of the inverse, which is true. If we graph the inverse, it does pass the horizontal line test, but that's not why this inverse relation, we want to say it's 1-to-1, I guess.
Yeah, okay. Because that's why it passes the test or becomes, isn't it?
One to one means it passes the horizontal line test. So if it were me, I guess I would choose this one as my final answer.
Okay.
All right, let me know when you're ready for us to move on to a new question.
I'm ready. These
Okay.
ones really confuse me.
Sure. Yeah, so we're gonna make a small picture here. So I'm gonna pick a couple numbers, 1, 2, and 3, and then 4, 5, and 6. Okay, and you've probably seen these in textbooks before.
Yeah.
Try to clarify this. So let's say that 1 goes to 4, and 2 goes to 5, and 3 goes to 6. Okay.
Right.
This is a function, and we're not going to talk about why it's a function. We're going to talk about why something is not a function in a moment. Okay.
Okay.
So 2 is still going to go to 5. Okay. But now 2 is also going to go to 6. Okay.
Right.
Well, imagine you were building a box that took in a number 2. What are the possible outputs?
It'd be 5 and 6.
5 and 6. Okay. So now let's put this into like a real situation. Let's say you go to a store. Okay. And you come in there this would be like your friend paying 5 and you paying 6.
Right.
Does that seem right?
No.
No, that wouldn't be very right. Or any other scenario you can think of where you're expecting one output, but it could be another.
Right.
Okay? And that's the issue here. It's like you don't know what to expect in terms of the output from the input. So now we'll look at some ordered pairs, and I'll give you some other rules here. Unfortunately, I'm giving you rules that only work for these problems. They don't work sort of generally.
Okay.
So the recipe here, the algorithm, is to first look for duplicates in the X.
Got it.
So what do I mean by that? In this first one, are there any other negative ones in the X? So there's -1, 0, 1, 5.
No,
No.
there's no other negative ones.
But and then when you look at them all, 1, 0, 3, 1, and 5, and 7,
Mhm.
are there any duplicates?
No.
No. Okay. So let me go through here. Oh, I see. Oh, I'm sorry. This is talking about the inverse. So we have to find the inverse of each of these. I'm sorry. So we need to find the inverse by switching the ordered pairs for each of them.
Oh, so we switch all of them and then still check if there's
Yes, then we check
duplicates?
that. Yeah. And so we'll
Okay.
do that in a moment. Okay, so now, does this have any duplicates in the X?
Yes.
And see, one goes to 0 and one goes to 7.
Mm-hmm.
So the analogy is like you input 4, or you ask for 4, and you don't know whether you're paying 0 or you're paying 7, and that's no good.
Right.
Okay.
Okay.
Now, if this other point were 0, that would be okay, because then they both go to the same thing, but it doesn't. It goes to 7. So we're gonna do the same thing this next line here. We're gonna flip the values. We got 2, -1, 4, 0, 5, 1, 4, 5, and 2, 7.
So it happens again with
Happens
the 4.
again with the 2 and the 4 and the 4. Oh, that's true. I didn't catch that. Yeah, it's also problematic with that. So those are both out. Okay. So let's look at the next one here. 3, -1, 4, 0, 14, 1, 6, 5, and then 2, 7. That one's looking pretty good
Yeah.
because there's no duplicates in the X.
Right.
So let's look at the last one here and make sure that it is wrong. 4, -1, 4, 0. And it doesn't look like we have to go any further than that, because
Yeah.
that is a problem.
Okay, that makes sense. So just reversing them and seeing if there still is any duplicates. But otherwise, if it wasn't inverse, you would just write it normally and try to find the duplicates,
Yes.
or just like look
Yes.
at the normal answer.
Exactly. So why don't you do this for me? Why don't you try number 6 on your own?
Okay.
Take a minute or two and just check with me when you think you've got your answer for this one.
Mm-hmm. So the first one has no duplicates in the X.
That's right. So are you going with A as your final answer?
Yeah.
Yeah, it actually looks good here. Because so the way I can do this do quickly is I look at the Y values and see if there's any duplicates. And there's 3 there, so that one's out. And then this one has, sorry, that one duplicates in 8.
Mhm.
And then the last one's duplicates in 1. So yeah, that's your
Okay.
final
That
answer on
makes
that
more
one.
sense.
Okay, well, we've covered everything on this document that you sent me.
Uh-huh.
Is there some other stuff you can put together for us to look at? What would you like to do with the rest of the time tonight?
Yeah, that's my turn. I would just like to go over like more, I guess, just like inverse problems that if you can come up with some, it would
course.
be helpful to just go over the process again, because with step-by-step ones, I have to do them a lot before I remember them, like in my brain.
Sure. Yeah. I mean, they're going to be a little bit different than what you're getting here. So
Yeah,
let's just do a couple that I've already kind of mentioned here. So let's say f of x equals 1/2 x minus 3. I want you to find the inverse of x, and you do that by those 3 steps that we talked about.
right, okay.
So you write y instead of f of x. You switch x and y, and then you solve for y.
So I put them in parentheses so I could keep them separate, but it's x plus 3 divided by 1/2.
Okay. So
Equals one.
so what you said is correct, but you would never leave a fraction inside a fraction like this.
Right,
So do you remember how to undo that?
you would times them.
Well, yeah, and you actually, like in the previous step here, when you had 1/2 times y, you would multiply by 2 to undo it rather than divide by 1/2.
Okay. Okay, that
So-
makes sense.
Okay, so let's try another one here. We'll just increase the difficulty slightly. Let's say that f of x equals the x to the third minus 4 divided by 3.
Okay,
So your step 1 is always just to kind of rewrite it. Step 2, you're going to switch x and y. Okay, and then step 3 is really the most challenging one, is because you got to solve for y. And this is kind of testing your prior knowledge in math. So what's the first step here to solve this for y? What do you need to undo first?
need to undo the -4.
You might think that because you're used to getting rid of addition, subtraction first. The numerator is actually in parentheses, so you undo division by 3.
Okay,
So you undo division by 3 by multiplying by 3 on both sides,
okay.
and that clears it out.
-4. Okay.
So 3x equals y cubed minus 4.
Uh-huh.
Okay, so now we're trying to get to y. Now
So
you undo.
add the 4.
That's right.
First, let me have 3 times x plus 4 equals y cubed.
Now, how do you undo a cube? Do you recall that?
That's the square root, and that's very complicated.
Well, so this one's different. It's a 3. It's not a square.
Then I have no idea.
Okay, so to solve x squared, you
Uh,
take a square root. Do you remember that?
yeah.
This is actually the same as raising it to the 1/2 power. Have you
Okay.
seen that before?
No.
Okay. So this is then a little bit out of scope for you, but you would raise it to the 1/3 power on both sides.
Okay.
And I'll just finish this off here. It's y equals 3x plus 4 to the 1/3 power.
Okay.
All right, let's see here. So let's just try something a little bit different here. Let's say I tell you that I want you to graph this right here, negative 2x plus 3. What is the slope and what is the b value?
So the slope is the -2.
Okay.
And the b or y or whatever is 3.
Okay. So where do you start when you graph this? Do you start with the slope or the b value?
Slope.
You actually start with the b value.
Okay.
So the b value tells you where it crosses the y-axis. Where does this cross the y-axis? At 3?
Yeah. At 3.
Now, what does the slope of -2 mean?
That you put a dot at -2.
So this is actually a fraction. It's actually a fraction. -2/1 is a fraction. -2 means you're going to go down 2, and then the 1 on the bottom means you're going to go right 1. But it's from this starting point. So you go
Okay.
down 2, right 1. Down
Oh,
2, right 1. Down 2, right 1.
okay. Because it's the, oh, yeah, I did not know that.
I think you do. I think it's just been a while since you've done a problem like this.
Probably.
Okay, so I want you to find the inverse of this now.
Inverse.
The inverse of y equals -2x plus 3.
Wouldn't that be, okay, that would be 2 and -3.
No, you're going to find the inverse. You're going to find the inverse. So the 3 steps. Remember we did that
Right.
in some earlier questions here.
Yes.
You're gonna switch x and y, and then you're gonna solve for y. Okay, so
Got it. So x -3 over -2.
okay, great. Now we talked about this earlier. You actually have to divide both of these by.
Right.
So we can do this in pieces here. It's x over -2, and then I'm going to do -3 over -2 equals y. How do you rewrite this first part? Do you recall that? You're not supposed to leave the negative in the bottom. That's the kind of the key there.
Yeah, I know that.
So this is -1/2 x. And then when you have a negative divided by a negative, what does that become?
Positive.
So this is 3/2. Okay,
Right.
so what is the slope and what is the b value of this one?
So the slope is -1 over 2.
Okay, and what is the b value?
3 over 2.
Okay, so in terms of like words, when you have a negative slope, is that up or down?
Down.
It's down 1, and then it's always right, whatever the bottom number is, which is
Okay.
2 in this case.
Down 1, right 2.
All right. So let me quickly pull up our notes from last week. There was another concept that I think I want to look at real quick with you.
Okay.
When we have extra time like this, what I usually do is go and look for some things that maybe at the time didn't seem important, but we have a little bit more time now to look at.
Mhm.
So just pulling up the notes from last time. Okay, so yeah, let's do this. So let's say I asked you to do the following. I wanted x plus 4 squared.
Okay.
Okay, the correct answer to this is you have to first rewrite it in this way.
Right. Yes.
And then you have to do what's called FOIL.
Foil.
So FOIL means to take the first term times the first term. So what is x times x?
X to the squared power?
X squared, yeah, x squared, x to the power of 2. O means the outside, so it's x times 4. What is x times 4?
X 4x, sorry.
4x, it's we as a preference put the coefficient first. I is the inner, so 4 times x.
It is in the 4x.
And then L means the last in each, 4 times 4.
Yeah. 4 times 4. Oh, sorry. 16.
16, yeah. So then you combine like terms. Generally, you can combine these two.
Right, and then you get 8x.
Good. So if you follow that, I'd like you to try this one on your own, please.
I do have a question though. So how do you know when you're gonna add it or subtract it? So like the whole question, we added x to like everything. We added everything. Is that because that's what is in the parentheses is x plus 4? That's why we had plus all of them.
That's why you write it twice, is
Yeah.
because the 2 means to write it twice. I don't know if that answers your question.
X squared plus 10x plus 25.
Okay, so I heard x squared plus 10x plus 25.
Yeah.
Very good. Okay, now it's also possible that you could get a problem that looks like this, where it's x minus 3 squared. And this
Okay.
means x minus 3 times x minus 3. And it's the same type of problem. It's a FOIL problem.
Mhm.
The difference is not these negatives, they go with the number to the right of it.
Okay.
Okay, so when you're doing F, well, that doesn't matter. It's x squared.
Right.
But when you're doing O is x times negative 3 now.
Okay. So then I would go negative 3x and then negative 3x.
That's right, negative 3x. And then the last one is a negative 3 times a negative 3, which is
Positive 9.
positive 9.
So then that's
These don't cancel. They're both negative, so they just combine.
Negative 6 plus 9.
Okay, so try this one on your own, please.
Okay.
And let me know when you get your final answer.
Got it. So x squared minus 12x plus 36.
Perfect. Okay. So now I'm going to give you some different problems, but they're the same recipe. So
Okay.
what if it's x minus 2 times x plus 3?
Okay. 2.
So that's
X squared. 2 negative 2x.
so this time the outer and the inner, you have to combine them, but they don't just add or they don't just subtract. You have to see what it comes up, what it works out to. So this becomes just 1x.
So you minus the 2x from the positive 3x.
That's right. Okay, so let's try another one here. Let's go with x minus 5, x plus 2.
First x minus 5. Okay.
So it should look like this: x squared plus 2x minus 5x minus 10. Is that what you wrote?
Yeah, that's what I got,
Okay, now this time it's 2x minus 5x.
which gives you 3x.
Is it positive or negative?
Positive.
But this one's more negative.
Oh, right. So it's negative.
Negative 3x, yeah. Okay, so really quickly with our last few minutes here, can you give me the answers to these two questions?
Yeah, 3 and
Okay.
negative 3.
Good. Okay, let's try one more. Couple more here. What is 6 minus 8?
Negative 2.
Okay, and on the right here, or the bottom here?
Oh, give me a second. Negative 14.
All right, very good. Okay, a great job today. I will send you the notes here shortly,
Okay.
and I will see you next time.
Thank
Have a
you.
great night, Emma.
Thank you.
Bye now.